Hello everyone. This video is on the Knewton Alta assignment for section 6.7 part 2 called Scientific Notation. So in this video I'm going to be doing a preview version of this assignment, so please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are all the same, the structure should be similar, so I'm hoping that watching me do these here helps you out in some way when you work on the assignment yourself. Alright, so on the assignment page you should be seeing the title, the mastery bar telling you how far along you've gotten, the objectives. It looks like there are 3 objectives for this assignment. Under the current objective, there should be a question related to that objective, and at the bottom of every question should be a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. It's for instructors only. But you will have a more instruction button. If you're struggling with a topic or a question, click on this and you'll be taken to a page with some reading or videos to study, and then you'll be given questions related to that instruction, and completing those questions is another way to progress through the assignment. Okay, so the first objective I'm looking at here is convert from decimal notation, which is the way numbers are usually, you're used to seeing them, decimal, base 10, right, to this thing called scientific notation. Right, so I'll talk about that real quick before I get to this example. So what does it mean? What is scientific notation? Alright, a number is in scientific notation if it is written in the following form: as some number a times and then a power of 10, say 10 to the n power. And this value of a has to be greater than or equal to 1, but also at the same time less than 10. Alright, so basically a number between 1 and 10. So a number between 1 and 10 times some power of 10. So for example, 2 times 10 to the 3rd power. This is a number written in scientific notation. And what we're going to be doing is going back and forth between scientific notation and the regular old decimal notation, where you just basically multiply this out. Now remember, 10 to the 3rd power, that's 1,000. Right, this is 2 times 1,000, which the power will tell you, the power on 10 will tell you how to move the decimal point. A positive power of 10 means move the decimal to the right that many decimal places. Move decimal right. A negative power of 10 tells you to move the decimal to the left that many places. I mean decimal point. I move the decimal point to the left. So here, if I take the number 2, remember the decimal point on a whole number is after it, and then times 10 to the 3rd power means move the decimal point to the right 1, 2, 3 places. And then every time there's an empty spot, you're going to fill it with a 0. So 2 times 10 to the 3rd is 2,000. Right? That's 2 times 1,000. So in scientific notation, 2 times 10 to the 3rd. Decimal, 2,000. Here's another one. 1.34, that's a number from 1 to 10, times, say, 10 to the 5th. Right. And so a number from 1 to 10, but not including 10, times a power of 10. Well, this means take the decimal point and move it to the right 5 places. 1, 2, 3, 4, 5, and in every empty space you throw a 0, right? So it's 134,000. Right, 1.34 times 10 to the 5th. Right, 10 to the 5th is 100,000. Right, a 1 with 5 zeros after it. So it's 134,000. All right, then one more example of this. With a negative power, say I have a 1.597 times 10 to the negative 4. Right. That's in scientific notation. So I take, this 10 to the negative 4 means, move the decimal point to the left 4 places. So from here, 1.597, 1, 2, 3, 4, there's the decimal point now, and then all the empty spaces get filled with zeros. So this is 0.0001597. And then, of course, usually like a whole number before the decimal, so if there's nothing there, just throw a 0. There's 0.0001597. And that's the equivalent decimal form. Right? And we're going to be going back and forth between these. Right? We're going to be going back and forth between these. But it's just a number from 1 to 10, but not including 10, times the power of 10. That's a number written in scientific notation. All right, so this first example, the first objective we're looking at is convert from decimal notation to scientific. All right. So we're given a number here in decimal notation. It says, the probability of winning the 2010 Mega Millions lottery was about 0.00000000057. So it's 8 zeros after the decimal point and then 57. Write this number in scientific notation. And that's usually what scientific notation is for, is to write really, really small numbers or really, really large numbers in a more compact way. So here we have 0 point, and then I said there were 8 zeros, right? And then 57. All right, this is in decimal form, right? Because it's not in this a times a power of 10 thing, a number from 1 to 10 times a power of 10. And again, let me just make sure I'm counting that number of zeros correctly. 0, 0, 0, 0, 0, 0. Yeah, 8 zeros and then 57. So to convert to scientific notation, you're going to first move the decimal point until you get a number from 1 to 10. All right. So I'd move this decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9 places, right? This was 9 places I had to move the decimal point to get it to be a number between 1 and 10, right? It's 5.7. And then I just got to multiply this by some power of 10 to move it back. Right? I want this to end up being 0.000000057. Well, if I have 5.7 and I want to get 8 zeros 57 like this, I need to move this decimal place to the left 9 places. Right? I need to move this decimal point left 9 places to get back to the original number. And if that's the case, that power of 10 needs to be 10 to the negative 9. Right? A negative power will move you back to the left, and a positive power moves you back to the right. And there you go. This is it. This is what they want, that same number in scientific notation. So back in the assignment, that's what I'm going to type. 5.7. There's that number from 1 to 10. And then they got the little time symbol here. Alright, and you can put just in parentheses if you want. There's nothing wrong with that either, but I don't know, for some reason a lot of textbooks they have the times symbol. And then a power of 10, right? 10 raised to the negative 9 power. That is the same number, this 0.00000000057. That's the same number, just written in a much more compact way. All right, then after you submit an answer, you'll be told if you're right or wrong, and then given some sort of answer explanation. All right. Please read through the answer explanations, just to make sure you understand why something was right or wrong, and then hopefully you can learn from your mistakes or future questions. All right. So moving on. So sticking with the same objective, see we're given here a number. The average width of a human hair is 0.0018 centimeters, right? A number that's in decimal form, not in scientific notation. And we're asked to change it, convert it to scientific notation. So once again, on the same page here, the number we're given is 0.0018. Right, this is 18 ten-thousandths. Again, this is in decimal form. Now this is the same thing as, if I'm going to move the point until I get a number from 1 to 10. So here, no, here, no, here, yeah. If I move it there, it's going to be 1.8. That's a number from 1 to 10. And that was what? 1, 2, 3 places. All right, that was 3 decimal places that I moved the decimal point from. And then I got to multiply 1.8 by some power of 10 to move it back. I want this to be equal to 0.0018. So I need to take this decimal point, 1.8, and move it to the left 3 places. So I need 10 to the negative 3rd power. All right, that'll move it back to the left 3 places and give me 0.0018. So there's your scientific notation for the same number, 1.8 times 10 to the negative 3rd. And that's what I'm going to type. 1.8, right? Now, of course, the number can also be negative, right? I know I mentioned the number has to be from 1 to 10. So really, I should say the absolute value of the number. The absolute value of the number A has to be between, from 1 to 10, because it can be negative. But still, we got 1.8 times, and then 10 to the negative 3rd would move it, the decimal point back 3 places, left 3 places to give me 0.0018. Great. All right, next. All right, so this is going the other way around. Now this should be a lot easier. You're given a number that's in scientific notation and asked to just change it back, move the decimal place, move it back with the power of 10, right? Change it to its decimal form. So to reach escape velocity, a rocket must travel at the rate of 2.2 times 10 to the 6th feet per minute. Express this number in standard notation or decimal notation, right? Not scientific. Yeah, so this number we're given is 2.2. Right, there's a number from 1 to 10 times 10 to the 6th. Right, so this is in scientific notation. And then I have to change it to standard notation or decimal notation. And this 10 to the 6th, right? This 10 to the power of 6, positive 6. This is telling me move the point, move the decimal point to the right. It's a positive number, 6 places. And then fill any empty places with zeros. So if you take 2.2 and move the decimal point to the right, 1, 2, 3, 4, 5, 6, there it is now, and then fill these empty spaces with zeros, these empty humps. That's 2.2 million. That's 2,200,000. And there you go. That's the number in decimal form. 2,200,000 is the same as 2.2 times 10 to the 6th. And that's what I'm typing here. 2,200,000. Great. Alright, so another one of these. So here I have 1.35, 1.35, and some number from 1 to 10, times 10 to the negative third power. Right, and that's in scientific notation. We want to change to decimal. Just move the decimal point right. What would be the equivalent number to this? And this power of 10 is negative, right? That means move the decimal point left 3 places. So this will be equal to, and then if you take 1.35, move the point left 1, 2, 3, so now it's here, and then fill in the empty spaces with zeros. This is going to be 0.00135. Right, and then of course they usually pop a 0 in front of that if there's no whole number before a decimal point. And this is what they want. The same equivalent number in a different version, though, a different form. Decimal form, standard form, whatever you want to call it. 0.00135, right? 135 hundred thousandths. All right. So I'm hoping that's easy enough, right? After seeing a couple examples of each, going back and forth between scientific notation and standard or decimal notation. All right, now we get into a part where we're asked to multiply and divide. And the way you multiply these is just like you would multiply monomials, and you're using properties of exponents. So let me show you what I mean. So this example next I'm given is, we have 8 times 10 to the 7th multiplied by 7. It's 7.0, but I'm just going to write it as 7 times 10 to the negative 4th. All right, and this is similar to if you had 8 times x to the 7th and multiplied it by 7 times x to the negative 4. Remember how to multiply monomials, but instead of x we have 10, right? Instead of x to the 7th we have 10 to the 7th. Instead of x to the negative 4 we have 10 to the negative 4. Remember, you'd multiply these and make this equal to 56 x to the 3rd. Right? Multiply the numerical coefficients, multiply things with the same base, you add their powers. 7 plus negative 4 is positive 3. So you multiply these and divide these numbers written in scientific notation the same way you would as multiplying or dividing monomials. So this is going to be 56, right? 8 times 7 is 56, and then 10 to the 7th times 10 to the negative 4th is 10 to the 3rd. And remember what this means. Now they ask us to enter, they don't want us to enter the final answer in scientific notation. Say they want us to enter your answer as an integer or a decimal, basically in decimal form. Right? So just take 56 here, the decimal points after the whole number, and this is 10 to the positive 3. So move the decimal point to the right 3 places. 1, 2, 3, fill all those with zeros. This is 56,000. This is 56,000, the product of those two numbers. Now you could also change this back to scientific notation if you were like, hey, move it back 4 places, you got 5.6, and this would be 5.6 times 10 to the 4th, right? To move it back 4 places, make it 56,000. This would be scientific if they asked you for it, but they didn't ask me for it. They asked me for decimal, 56,000. Okay, good. All right. So another one of these, or this time we're doing division. All right, but it is the same concept. You divide these numbers in scientific notation the same way you would divide monomials, right, if you wanted. So there's too much clutter here. So new page. So we have 3.6 times 10 to the 1st divided by 9.0, or just 9, times 10 to the negative third. Right. Remember, you can think of it this way. This is the same thing as 3.6 divided by 9, 9.0, times, and then 10 to the first divided by 10 to the negative third. Remember how to break up a quotient of monomials into a product of two quotients. Right? We've done this. We did this when we were dividing monomials in section 6.5. Now 3.6 divided by 9.0, if you multiply by 10 over 10 here, this is the same thing as 36 divided by 90. And this simplifies, right? There's a common factor here. Again, I just times 10 over 10 on this. Times 10 times 10, make us 36 over 90, just to get whole numbers. And then 36 is 4 times 9. This is 10 times 9. Oops. And in fact, this can reduce even further. 2 times 2 is 4. 2 times 5 is 10. So this is 2/5. All right, yeah, because 36 is 18 times 2. 90 is 18 times 5. So this ends up being 2/5 times, and then this is 10 to the 1 minus negative 3. Remember that quotient property? You divide things at the same base. You subtract their powers, numerator power minus denominator power. Now 2/5 as a decimal, they want things as decimals. 2/5 is 0.4 times, and then 1 minus negative 3 is 1 plus 3, which would be 4. So I have 0.4 after dividing the numerical coefficients, and then times 10 to the fourth after dividing the powers of 10. And this tells me move the decimal point to the right 4 places, so I'll have 400. Not 4,000. Sorry, right, because if I take 0.4 and move it to the right 1, 2, 3, 4, yeah, that'll be 4,000. Right. So the final result here is 4,000. Now if they wanted this in scientific notation, that'd be 4 times 10 to the third, right, in scientific notation. A number from 1 to 10 times some power of 10, but again, you could easily you should be able to easily convert back and forth between those. So this is 4,000. Great. All right. So back to here where we're given a number in decimal and has to write in scientific notation. This one I'll just kind of count out. So we have 154,500,000. So I need to move the decimal point, which would be after the whole number. I need to move that to the left, 3, 6, 7, 8 places to get a number from 1 to 10 to get 1.545. All right. And then to move it back, I'd multiply by 10 to the 8th times 10 to the 8th, right? Because I moved the decimal point left 8 places to get a number from 1 to 10, and to get it back to be the same number as the original, I'd have to move it right 8 places, so multiply by 10 to the positive 8. So 1.545 times 10 to the positive 8 is the same thing as 154,500,000. All right. Same thing here, 0.64. Again, I move the decimal point to the right once to get 6.4, right, to get that number from 1 to 10. And then I'd have to move it back to the left to get 0.64 to get the original number. So I'm going to multiply this by 10 to the negative 1. 10 to the negative 1 tells me move the decimal point, back left 1 place to get 0.64. So 6.4 times 10 to the negative 1 is the same as 0.64, 64 hundredths. Okay, again, here's a number in scientific notation. See, okay, ooh, look at the question. And read the question, right? The gross domestic product for the United States in the first quarter of 2014 was approximately 1.71 times 10 to the 13th dollars. If you wrote this number in standard notation or decimal notation, it would be the number 171 followed by how many zeros? Well, remember, 1.71 would be, times 10 to the 13th tells me move the decimal point to the right 13 places. So 1, 2, there's your 171, and then 11 more. I'd have 11 zeros after this, and that's what they're asking for. How many zeros would be after 171 if I move to the decimal to the right 13 places? 171 followed by 11 zeros. Alright, so this one's just convert to decimal form. Oh boy, 1.5 times 10 to the 13th. So I move the decimal point to the right 13 places. So then I'd have 15, and then I'd move it, move it once, so you got 15, and then move it 12 more times. So you have a 1-5 with 12 zeros after it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's the number in decimal form. 1.5 times 10 to the 13th. 15 with 12 zeros after it. Okay. Then multiply and divide. Again, we divide here. If I do 2.4 divided by 6, that's the same thing as 24 divided by 60, which would again be 2/5 or 0.4. And then 10 to the negative 9 divided by 10 to the negative 6. Negative 9 minus negative 6 would be negative 9 plus 6. That'd be negative 3. 10 to the negative 3. So 0.4 times 10 to the negative 3. You move the decimal place to the left 3 places, so it'd be 0.0004. So again, if you wanted to write that out, go ahead. But I just basically did all the stuff they're explaining here out loud. All right, here we're multiplying again. Now here, enter your do not give answer inside. So it's again 56. 7 times 8, 56, and then 10 to the negative 1 times 10 to the 4th would be 10 to the 3rd. So 56 times 10 to the 3rd, that's 56,000. We saw something like this earlier. All right, take 56, move the decimal point to the right 3 places. That'll be 3 zeros after it. This is 56,000. Great. All right. Then I should just have a few more here. Oh, that's it. Thought I wasn't done with the other objectives. All right, and like I said at the top of the video, the questions I saw here may not be the same that you see when you work on the assignment yourself, but the objectives are the same. The structure should be similar. So I'm hoping that watching me or listening to me do these here helps you out in some way when you work on the assignment yourself. And thank you very much for watching.